Hi guys, today I'm going to show you how to do a image segmentation for three-dimensional images with the help of Unet architecture. So this is the Python Keras program. So I will tell you first you can load the Brats dataset and then you can unzip it. Again you can get the training images or training data, so you'll get the training data here. uh, there is two types, high grade tumor and low grade tumor. Then you can load all those library files which are all required. Then after initialization we are going to just design a convolution block to create the 3D model. So first, here we that define a convolution block. After that we have to design the unit. So here is the input image, number of filters, and how many is the dropout, and whether we need the patch normalization or not. So then this is the first block, first convolution block, next block. It is everything based upon the unit model only, but here it is the three-dimensional data because Brats is the three-dimensional data. Finally we concatenate from the uh, uh, block 4 and block U6, that means this transformed block. So this is the architecture of unit model. After that, define a function for standardize the image or normalize the image. Here you can take the slice of the data, taking the sender value to subtract the data to normalize it. So this is the code for normalization. Then define a function for find the dice coefficients to check the performance of the input and output and feed the data to uh, training. Then you just give the size of the input data. So here you can give the sizes 4. So 128, 128 row value, 128 column value, and 128 batch data. That means 4-dimensional slices, 128 slices, and number of uh, classes is 4. Here 4 classes there: core tumor, non-enhancing, enhancing, and normal one. So this is just load the unit model here, then provide the training options here, then combine the model and model summary. Then so now we construct the finish the construction of the model. Then we want to feed our data. So this is the path. Then just declare the 0 for the particular dimension of the data. After that, define the epoch, take all the image numbers from the all the slices, take the folder paths, automatically it's taking. Then here the ground truth, that means for mask image it's getting the mask image. Here this is the image of original one, this is the mask one. And then reshape the data and reshape the mask as well, and then just display the images and the mask. Reshaped all the data here. Print the number of classes and print the class weights. Finally make make that as a categorical format. So image reshaped image data to is the mask data, reshaped is our original data. So we'll get now all the data here by see data and image data. So data is the original data, and the image data too is the mask data or ground truth data. So we got the original and the ground truth data. Now we are going to train the data here. Once we train the data, we can save the model. Once we save the model, we can load the model here. Just we are saving the model here. So this is the architecture of 3D-Unet and how we are feeding the data. So once we train that, it is taking too much time to train, so I'm not training here. I just testing. I already trained, and I'm going. Now training is completed. Now we are going to test now. So same thing only, standardize the data, load all the library files, take the dice coefficients. Here we are computing the sensitivity and specificity. For that we need true, positive, true, negative values. So finally compute the sensitivity and specificity and get the sensitivity and specificity for all the patches. Then load the model. So once we load the model, we can give the path of the particular uh, images to 3D images to check out the test outcome. So here you can enter the image, input image, you can image and taking the folder file and taking the data and corresponding ground truth, reshaped it, reshape the data. Then we are going here only, we are going to test model dot evaluate reshape the data. So this is the ground truth, this is the original. So now we are getting the die score, mean die score and coefficients. For that means accuracy for all the classes, class 0, class 1, class 2, class 3, enhancing, non-enhancing, core, tumor and normal. So this is the outcome of all the data, sensitivity and specificity and die score coefficients. Then this is used to showing all the results. Just to give the image number and the slice number. Then we can give the modality, whether 1 or 2 or 3, which one we want to check. Reshape it. Finally, we can show the images of that 64th data. Modality is flare, ground truth and segmented result. So this is the input image, this is the ground truth image, so this is the outcome of our 3D-Unet model. So here you see this is the background, this one kind of non-enhancing or enhancing tumor, core tumor and the another one. So we have taken 4 classes, right? So we will be getting the output as in the form of 4 different colors. So here instead of taking 64th slice, we can take any slice and it will give the result according to the slice number. So it is taking too much time to train. So this is the whole model, how to load, how to train a 3D-Unet model. So I think you understood. Once again, I'm just explaining. Just to load all the library files, then construct a uh, convolution block, then define the unit model according to the unit architecture, then standardize the image, then find the dice coefficients for training, then define the model 3D-Unet and compile it, then give the path of the data, and training is happening here only for all the epochs. Uh, uh, Combine the data one by one, that means original and mask data. Finally fit the data, that is training. Here once trained, we just save the data. After that, in order to testing, just to load the data. Same thing only, once we take the just load the data here and give the path of the data and check which model we are taking, everything, then checking the sensitivity and the positive. Finally, if you want to display the data means here you can give the image slice number and it will produce the result according to the input data. So this is how we train and test the 3D-Unet model for 3D data. That is the 3D data, that is why. So it is in the form of NW. Hope you understood uh, everything what I said here. So you can also try it for another 3-dimensional images by using this 3D-Unet. If any doubt means you can uh, ask me in the WhatsApp or you can mail me. Thank you. Thanks for watching.